Hello, I'm going to walk through each question on the Chapter 7 practice test, so let's get started. Number 1 is under the learning target. I can multiply and divide monomials, so we need to simplify this expression and write our answer with positive exponents only. I'm going to go ahead and zoom in here on number 1. And now I'm going to distribute the 4 to everything inside my parentheses. I don't want that marker. Here we go. Do that to both sets here. So I get 3 to the 4th, x to the 16th, y to the 8th, and z to the negative 4th. There we go, that's my first one. And now my second one over here is 2 squared, x to the negative 8th. Well, no y's. Started writing a y. Z to the 2nd. I'm going to combine my variables with this, my exponents with the same base, so my variables. I'm going to combine my coefficients. So 3 to the 4th is 81, 2 squared is 4, and 81 times 4 is 324. I have x to the 16th and x to the negative 8th, so if I take x to the negative 16th and I add 8, that's going to give me just x to the 8th in the numerator. X to the 8th. I have y to the 8th here, and no y's on the other term, so I just have y to the 8th. And then I have z to the negative 4th and z to the 2nd. So if I combine those, I have z to the negative 4th plus 2, which is z to the negative 2nd, but I can't leave that in my numerator because I need only positive exponents with what the directions have said, so I need to move that to the denominator, and then it becomes positive. So my final answer is 324, x to the 8th, y to the 8th, z squared. Alright, number 2, we also have to distribute here. So I'm going to distribute this negative 2 to every term inside my parentheses, and when I do that, I get 3 to the negative 2nd, a to the negative 14th, b to the positive 6th, all over now in the denominator is 4 to the negative 2nd. I'm going to look at all my negatives, exponents that I have, and everything I've circled I need to flip to the other side of the fraction bar to make positive. So when I do that, I get 4 squared and now in the numerator, and 3 squared in the denominator. A to the 14th also goes to the denominator. B to the 6th can stay on top because that's positive and don't have to move it. Now I just simplify, so 4 cubed is 16, b to the 6th, all over 3 squared is 9, a to the 14th. So 16 b to the 6th, all over 9, a to the 14th is my final answer. Number 3 says express the volume of the solid as a monomial. So if we think about volume, volume is length times width times height. So I know my length, my width, and my height over here. Actually, I'll circle them all, and I'm just going to go ahead and multiply. So 3x times 2x times x, and I'm going to go ahead and combine my coefficients to give me 6. Combine my x's, and x to the first, x to the first, and x to the first gives me x to the third. Since I did find volume, I could label here units cubed. Final answer. Number 4, we have to simplify. Assume that no denominator equals 0, and write answers with positive exponents only. So let's look at number 4 now. On number 4, the problem here is in parentheses, but it's not to any power. So we don't need to worry about distributing anything here. We just have to look at simplifying. So I'm going to look at the 4 and 64, excuse me, and if I divide by 4 from both of those terms, I'm going to get 1 over 16, right? So just simplify my coefficients that I can. Now I'm going to look at P, Q, and R, and I'm going to circle the negatives that I have to flip. P can stay on top because that doesn't have any negative exponent. Q needs to flip to the bottom. So Q to the 12th becomes positive, and then R to the 4th also goes to the top of the numerator. And then I don't even really need to write this 1 here. It's there, but it's a silent 1, so I'll rewrite this answer to say PR to the 4th all over 16 Q to the 12th, and that is my final answer. All right, number 5 has a little bit more going on. I do have to distribute my exponent here to everything, and I always like to draw arrows to remind myself to distribute that -3. I'm going to rewrite everything I get when I distribute that -3. So 5 to the -3rd, Q to the 6th, R to the -18th, S to the -3rd, all over 6 to the -3rd, S to the 9th, Q to the -3rd. And I'm going to circle in red everything that's negative that I do have to flip. Okay, and when I do that, I'll rewrite down here. Below, I get 6 cubed over 5 cubed. If I bring Q to the -3rd up, but I already have 6 up there, I get Q to the 9th. I'm going to bring down R to the 18th. That becomes positive. And then I do have S to the 9th down in the bottom, and if I bring down 3, I'm going to combine those and get S to the 12th. So now I'm going to go ahead and simplify my coefficients, and 6 cubed is 216, 5 cubed is 125, then I will leave my exponents as they are, Q to the 9th, R to the 18th, S to the 12th, and then I don't have any negative exponents left, and I've simplified everything I can because there's nothing that goes into both 216 and 25, so I will leave my answer like that. Number 6, if we look at the numerator of this fraction, we have, some terms in parentheses to the 0 power. So all of that, anything to 0 power actually is 1, so I can rewrite that as 1. And now I'll distribute in my denominator and simplify that. So I get 1 over 3 to the 4th, A to the 20th, B to the 24th, and then I'll go ahead one step further and I'll simplify 3 to the 4th and get 1 over 81, A to the 20th, B to the 24th, and that is my final answer. Next learning target says I can use scientific notation. So for 7 and 8, we are going to express each number in standard notation, which means if I have my number written out here, 6.287 times 10 to the 7th, I'm going to move my decimal 7 places to the right. So 1, 2, 3, 4, 5, 6, 7. Fill in those spots as zeros. And then if I rewrite this answer, I get 62,870,000. If we look at number 8, we are going to do the exact same thing, except we have to go to the left because I have a negative exponent. So now when I draw, my steps to the left of 6, I'm going to do that this way. 1, 2, 3, 4, 5, 6. Fill in with zeros, and I should have 5 zeros there. So 0.1, 2, 3, 4, 5. 3, 5, 2 is my final answer. And for numbers 9 and 10, we have to express each number now in scientific notation, so opposite of what we just did for 7 and 8. So now I need to write some number times 10 to the some exponent, and I'm going to make sure my first number here that I underline now in orange is between 1 and 10. It can be 1, but it cannot be 10. So let's see here. I'm going to have 1.586 times 10 to the, so if my decimal were to be right here, I'd have to go back 1, 2, 3, 4. So it's 1.586 times 10 to the -4th. All right, let's look at number 10. Same thing here. I will write my first number as 1.4 times 10 to the, now let's count here. I would have 1, 2, 3, 4, 5, 6, 7. So 1.4 times 10 to the 7th. So numbers 11 and 12 are still under the scientific notation learning target. And it looks like number 11 is a multiplication problem and 12 is a division. And we must write our answer in both scientific notation and standard form. So let's take a look at number 11. I'm going to zoom in here. And I'm going to go ahead and multiply first 7.4 and 4.3. So 7.4 and 4.3, and I get 31.82. And then I'm going to look at my exponents with the same base. So here with a 10, and negative 3 plus 6 is positive 3. So I get 31.82 times 10 to the third. But we're breaking a rule. We cannot leave our first number greater than 10 here, so I must move my decimal one place to the left. And when I do that, I originally wanted to go 3 spots to the right, 3 decimal places, but now I'm already going 1 to the left, so that means I have to add on a decimal because I have to go 1 additional spot to the right. So I get 3.182 times 10 to the fourth. Oops, excuse me, it's not 10 to the fourth, that's look like 104, 10 to the fourth. And then my other form, I would then move my decimal over 4 places and get 31,820 for standard form. So there's scientific notation and standard form for 11. We'll do the same thing here for number 12, except now we will be dividing. So we'll start by taking 95 and dividing by 2.1. So I'll circle these here. 95 divided by 2.1 is 45. Ooh, so over 10 again. Of course, Miss Roddy would pick a problem like this, right, to show that you know how to move your decimal spot over. And this number goes on for a while. 45.23809524, and it goes on in my calculator. I'm going to stop and round there. As long as you round appropriately, you will be just fine on your test. And I'm going to look at my exponents that have the base of 10. And 2 minus 5 is negative 3. So I end up getting times 10 to the negative third. There we go. And I realize on my answer key I actually rounded to the nearest hundredth right there. So if we did, this 8 would make the 3 go up to be a 4. So I'll go ahead and do that to keep that consistent, I just realized. But yet we're breaking a rule, right? I have to have this whole number be between 1 and 10, so I need to make this, move the decimal over 1 spot to be after the 4. So when I move that over, I originally wanted to go negative, 3, so 3 to the left, and I'm already going 1 spot to the left, so that will make my exponent go down 1. So my answer will really be 4.524 times 10 to the negative second. Again, I just rounded to the nearest hundredth, which then in standard form would be 0.04524. I got both forms, so I am done with that problem. Right, number 13 and 14 fall under the learning target. I can add and subtract polynomials. So I'm going to take my highlighter right now, and I'm going to highlight all my like terms. So 2x, and there's negative 3x. Let's do x squared, 2x squared, and then let's pick, let's go green, negative 7 and 8. And I'm subtracting these here, these polynomials. So let's first look at my x squared so I can get my answer in standard form. So I have in red x squared minus 2x squared. Oops, gotta go back to the pencil. And to give me negative x squared. And then I'll look at the x's in the orange, and 2x minus a negative 3x, so be careful, chop chop, is really adding, so I'm going to get plus 5x, and then my negative 7 in green minus positive 8 is negative 15, and I've combined all like terms, so that problem is finished. Let's go over to 14 here, and a little bit more going on, right? I'm going to have to distribute a little bit before I can start combining like terms. So I'm going to distribute right there, then even distribute that negative. So I end up getting y squared minus 4y minus 6 plus 2y squared plus 10y minus 6 minus 6y squared plus 2, right, because that double negative. Now let's go ahead and look at the, oops, I don't want that. I want the highlighter. Let's look at the y squareds, y squareds, y squareds. And let's combine those, and I end up getting y squared plus 2y squared is 3y squared, minus 6y squared is negative 3y squared. Now let's look at, change colors here, orange, and let's look at the y's. So negative 4y plus 10y, and that's about it for y's. So negative 4 plus 10 is plus 6y, positive 6y. And then last but not least, let's look at negative 6 minus 6 plus 2. Negative 6 minus 6 is negative 12. Negative 12 plus 2 is negative 10. And that's my final answer color-coded for you. Let's move on. All right, number 15 is under the learning target. I can multiply binomials and find special products. And I'm going to show all my work. So I'm going to, for number 15, use the FOIL method. So 4x times 3x is 12x squared. 4x times negative 2 is negative 8x. 3 now times 3x is positive 9x. And 3 times negative 2 is negative 6. Oops, there we go, negative 6. Now I'm going to combine my like terms. So negative 8 plus 9 is going to give me a positive 1x. So I'm going to get 12x squared plus x minus 6 for my final answer. Now number 16 is a little bit different. Right? It's a special product. It's a square of a difference. So really, if I were to write this out, it would be 5h minus 4 times 5h minus 4. And I could use the box method. I could FOIL. Or if you remember that rule that we learned, we could also use that. So I'm going to use that rule, and I'm going to remember that I square my first term to give me 25h squared. Then I'm going to, for my middle term, find the product of 5h and negative 4, and then times that by 2. So 5h times negative 4 times 2. And if I really want to show my work, for my first term, that was 5h squared, right, to give me 25h squared, and that's 2h squared, so that's not right. 25h squared, and then 5h times negative 4 is negative 20h, times 2 is negative 40h, and then last but not least, to get my last term, I would square negative 4, which is my last term, to give me positive 16. And I could double check that using FOIL or the box method, but I know I'm right, so I'm going to move on. Number 17 now, there's quite a bit going on, right? I see a couple things that I could put together right away that would be easier to complete this problem, specifically x minus 5, x plus 5, and x plus 9, and x minus 9, because these are special products rules. So let's look first at the x minus 5 and the x plus 5. That's a special product rule because it's a product of a sum and difference. So that will give me x squared minus 25. And then for my x plus 9, x minus 9, that's also a product of a sum and difference. That will give me x squared minus 81. Now I'm left with multiplying these two binomials together. I'm going to use the box method now here as I complete this. I'm going to write x squared minus 81 on top, x squared minus 25 down below. Now let's put the product of the terms inside the box. So x to the 4th, negative 81x squared, negative 25x squared, and then negative 81 times negative 25 is 2025. And I'm going to put together my like terms here. So I'm just going to use a little highlighter and put together my like terms. And I get x to the 4th. Negative 81 minus 25 is negative 106x squared, and then plus 2025, and that there is now my final answer. For number 18, I need to multiply polynomials and find each product. So I'm going to use the box method here. You could use horizontal method, whatever works for you that you've used before, go for it. I'm going to use the box method here, make a 2 by 3. So a minus 4, a squared minus 5a plus 3 right there. And then I'm going to multiply a cubed, negative 5a squared, 3a, negative 4a squared, positive 20a, and negative 12. I'm going to look at my like terms here. I'll even highlight some of these. And I have a squareds, and I have a's, and it looks like that's about it. So I get a cubed, and let's combine negative 4a squared minus 5a squared to give me negative 9a squared. 20 plus 3a is 23a, and then minus 12. Let's move on to the next problem. All right, now number 19, I'm going to make a 3 by 3 box here. I want to use a box method again, so 3 by 3. I'm going to put x squared minus 6x and 2, 2x squared, 7x, and negative 4 there. I'm going to find the product of these terms now. So I get 2x to the 4th, 7x cubed, negative 4x squared, negative 12x cubed, negative 42x squared, and 24x, 4x squared, 14x, and negative 8. And now let's look at like terms. I'm going to highlight any that I see here. I see I have x cubes, I have x squareds, and I have x's. So let's combine these now, and I'm going to get 2x to the 4th, negative 12x cubed plus 7x cubed is negative 5x cubed, and then 4x here in the bottom and negative 4x squared up there cancel out, so I'm just left with minus 42x squared, and then 24x and 14x give me 38x, and then I just have minus 8. And I've combined all like terms, made sure I've put everything together from the box method, and I'm done with that problem. All right, number 20 is a long equation that we need to solve, and I see that we need to use the distributive property, so I'm going to go ahead and do that first on both sides of the equation. I get 7m squared plus 35m minus 63 plus m equals 7m squared minus 2m plus 13. I'm going to solve this equation, and right away I see I have 7m squared on both sides, so those will actually cancel out. And I'm going to combine 35m and 1m and get 36m minus 63 equals negative 2m plus 13. I'm going to move all the m's to one side and the numbers to the other. So I'm going to add 2m, same time add 63, and I get 38m equals 79. And then the last step here would be to divide by 38 to isolate m, and 79 divided by 38 is 2. Now a way to check your answer for this test would be to plug 2 back in for m wherever you see this, but I know that I am correct, so I'm going to go on to the next problem. All right, we have one more equation to solve here under this learning target, so I'm going to go ahead and distribute this 3 here and get 3x plus 3 minus 5 equals 3x minus 2. Now I'm going to combine like terms, and I get 3x, 3 minus 5 is negative 2 equals 3x minus 2. Now this equation is pretty unique in that we have the same thing on both sides. Doesn't matter if I were to like subtract 3x here and my x's cancel out. I mean, I would still get negative 2 equals negative 2, and you have the same number on both sides. And that, negative 2 will always equal negative 2, so it really doesn't matter what you have or what you plug in. The solution to this problem is all reals or all real numbers. All right, now we come to the application problem. So it appears that we have to find the area of the shaded region. So let's look a little bit closer here at 22. And I need to find, again, the area of the shaded region. So I'm going to figure out the area of my larger rectangle and subtract the area of my smaller rectangle. So what I have here for the larger rectangle is 5x plus 4 times 2x minus 1. I'm going to FOIL here, so I get 10x squared minus 5x plus 8x, oh, that doesn't look like an 8, plus 8x minus 4. And I'm going to combine the x's, and negative 5 plus 8 is 3. So I get 10x squared plus 3x minus 4 for the larger rectangle. Now, let's figure out the area for the smaller rectangle and get x plus 2 times x minus 1. Distribute, get x, or FOIL, x squared minus x plus 2x minus 2. Combine my like terms, and negative 1 plus 2 is positive x, so x squared plus x minus 2. Now that's the smaller rectangle. So now what I need to do is I need to take my larger rectangle, subtract my smaller rectangle. And when I do this, I see I have 10x squared minus x squared to give me 9x squared. 3x minus x to give me 2x. And then negative 4 minus negative 2, chop is really plus 2, to give me a negative 2. And I could write units squared because I did find area. Number 23 is similar to 22 in that I still need to find the area of the shaded region, but now it appears we have a rectangle, and inside the rectangle is a circle. So let's remind ourselves what the formula for area of a circle is, and that is pi r squared. So let's first go ahead and find the area of the outer rectangle. So I'm going to take 2x plus 4 and multiply that by x plus 4 and FOIL and get 2x squared plus 8x plus 4x plus 16. Combine my like terms and get 2x squared plus 12x plus 16. And that's for my outer, that's for my rectangle. And then over here, let's look at my circle. So I'm going to take x plus 3, it's my radius, and multiply pi times x plus 3 squared. So what that is that's really pi times x plus 3 times x plus 3. This is a square of a sum, so I can go ahead and use that rule and get pi x squared for my first term. My middle term is 2 times my first term times my last term. So x times 3 is 3x, times 2 is 6x, and then square my last term, which is 9. Again, that's all positive. And then what I can do is for your test, I'm okay, because I know this test is long and you only have your class period to finish this test, to just distribute pi and leave pi as the pi symbol. If you want to go ahead and say pi is 3.14 and multiply it by every number, you certainly could if you have that much time on your test. But if you don't, I'm okay with saying, pi or x squared pi plus 6x pi plus 9 pi. And now the last thing that we'll do here is we'll just simplify this problem, and I'm going to subtract each of these terms. And so I end up getting 2x squared plus 12x plus 16 minus x squared pi minus 6x pi, because again we're distributing this negative right here, and then minus 9 pi, and again we could write units squared for area. And I'm okay with leaving your answer like this because it is a long test, but if you wanted to go ahead and multiply pi and call that 3.14 by each coefficient, you can if you would like. But I'll leave my answer like that. All right, the last problem we have here is a word problem. So it reads, a rectangular swimming pool is 3 times as long as it is wide and surrounded by a deck 2.5 meters wide. So I'm going to draw a picture first, and I'm going to draw my pool here. Right, it's a pool. And then I'm going to draw a deck that surrounds it here, and that's the deck. All right, so we know that it's 3 times as long as it is wide, so if I call my width W, my length has got to be 3W because it's 3 times the width. And then in green here, I'm going to write, this is the deck, kind of make little sides there, and green is 2.5, so I'll write 2.5. Okay, now write an expression in simplified form for the area of the deck, and we just want the area of the deck. So I need to figure out my length and my width, and my length, I said those opposite. And to get, let's do this side first, this purple side, I'm going to take 2.5 here plus W plus 2.5. So 2.5 plus W plus 2.5 is really W plus 5. Then figure out this side up here in the red that I've drawn a line across. I'm going to add 2.5 plus 3W plus another 2.5 to give me 3W plus 5. So I know my length and I know my width, and I'm going to multiply those together. So I'm going to take 3W plus 5 times W plus 5 and FOIL that, but I also know I have to subtract the area of the pool because I only want the area of the deck. So I'm going to subtract 3W times W. So if I FOIL here, I'm going to get 3W squared plus 15W plus 5W plus 25 minus 3W squared. And let's combine like terms. I'm going to cross out my positive 3W squared and negative 3W squared. And 15W, plus 5W is 20W plus 25. And that is my final answer for just the area of the deck. Now part B says, if the area of the deck is 265 square meters, find the dimensions, width, and length of the pool. So I already know the area of the deck from part A is 20W plus 25. And then I know now the area of that is 265 square meters. So I have 2 items here that are telling me that they're the same thing. I'm going to go ahead and set those equal to each other. And then now when I solve for W, I'll be able to find that width and length of the pool because I'll be able, the width is W right here, and then the length is just 3 times whatever we get for W. So let's solve this equation here. I'm going to subtract 25, and get 20W equals 240. And then now I'm going to divide by 20, and 240 divided by 20 is 12. So I get W for the width is equal to 12. And then to find the other dimension, I need to take 3 times W, which is 3 times 12, and get 36. So 12 meters by 36 meters are the dimensions of the width and length of the pool. Thanks for listening. I hoped you were able to listen to a couple of these problems, and if you were unsure of what to do on some items, that you perhaps got some clarification. Good luck on your Chapter 7 test. You will do great.